Descartes Rule of Signs. I'll give you a chance to read the rules here. We have two, A and B. Okay, now for A, it says the number of positive real zeros. So in here, when you're working with Descartes Rule of Signs, you're just looking at the transition from plus to a minus or a minus to a plus, like a change of sign from plus to a minus or minus to plus. So here we have the term number of variations or number of changes of the sign. And for the number of negative real zeros, you're just plugging in negative x to your f of x and then do the same thing. Same as letter A, you're counting the number of changes or transitions from a plus to a minus or a minus to a plus. Okay? And if your answer would be greater than 2, then you subtract that by 2 to find the other possible number of positive real zeros or negative real zeros. So we have this term here, a positive even integer by a positive even integer. So there is the word or less than the number of variation by a positive even integer. Let's have an example. Let's say you're given with f of x, x power 4 minus 6x cubed plus 8x squared plus 2x minus 1. And then you're asked to determine the different possibilities for the number of positive, negative, or non-real complex zeros of this f of x. So for this theorem, you're not finding the actual zeros. You're trying to count how many number of positive real zeros, how many negative real zeros, or how many complex zeros. So on that rule, as you can see there, you have only A and B, so that for the positive zeros and the negative zeros. Okay, so we're looking at the transitions here. So the first rule, you're looking at plus sign here. It changes to a negative, so that's count as 1. From a negative going to a positive, so that's counted as the second transition. As you can see here, plus and then another plus here, so it doesn't change. So you cannot count that as one transition. But from the second to the last and the last term, you can see that there is a negative there, plus to a negative. So that's counted as 3. So when you write your answers, you're going to have how many positive real zeros. Your answer would be, the possibility would be a 3. Or remember the rules. It says you have to subtract by 2 if you have greater than 2. So that's 3 minus 2, or the possibility would be a 1, positive real 0. So either of these two answers, that would be the answer for the positive real zeros. Now next, for the negative real zeros. Now before we will find out the negative real zeros, I'm just looking at the number 3 here on our first answer. So if you have a 3, it means looking at the degree of the polynomial, which is 4. Remember, this is our indicator, how many zeros we have for this f of x. So that's 4. So it means that if your answer is 3 for positive real zeros, you have 1 for negative real zeros. So again, it's only 1, so that should be negative real 0. So again, it's 1 negative real 0. What's left? Or you can think about 1 complex 0. So that could be possible also. If your answer is 1 positive real 0, then since we have 4 total, that would be 3 negative real zeros. That would be the possibility. So now, how can we find the negative real zeros? Okay, from our rule in Descartes Rule of Signs, we have to plug in a negative x equals now negative x power 4 minus 6. Our x is replaced by a negative x. And then you have to do the same thing here, then minus 1. Okay, so let's get the result here. So it's a negative x power of a positive 4. That's an even power, so that should be a positive term. And here we have a negative x cubed, because there's a power of 3. Negative x times negative x times negative x cubed times a negative 6 becomes a positive 6x cubed. And then here, that's a square of a negative, that becomes a positive, so plus 8x squared. And then we have minus 2x minus 1. And then we look at the transition now, or the changes, or the variations of the sign. So we have a plus here, then transition to a plus. So there's no actually a transition, right? There's no change. You can only count if there is a change. So like a transition from plus to a minus, or a minus to a plus. So going to the next term, plus to a plus, no change. And then plus to a minus, so we can count that as 1 next. So that's one transition, or one change. So that would be a 1 there. And then after that, the last term is a negative. And there's no changes. It's a negative to a negative. So there's no change or transition between the two terms. So we can only count 1. So our answer here is 1 negative real 0. Okay, so it's just a singular 1. So it's a negative real 0. So sometimes it could be more than 1 for negative real zero. Okay, for now, this is only 1 0 here. Okay, so if you're going to make a conclusion, it would be 3 plus 1 that matches the 4 there. So this would be the fit of that answer. So it matches the answer or the degree of the f of x, which is 4. Again, 3 plus 1 is 4. So it means if you're going to think about what would be the possible answers here would be 3 positive real zeros and only 1 negative real zero. Total of 4 zeros. Now, remember in the last presentation, we graphed this to see the x-intercepts. Remember, the zeros are x-intercepts and the zeros are the roots. So by graphing this, you can actually double check your answer if you did the right conclusion. Okay, but when you provide your answers, it should be the complete one from the theorem. So that should be the one that I put in a box. Okay, let's show you the graph for this. Okay, as you can see in the graph, uh, the same function that we're trying to plot here, it's the x power of 4 minus 6x cubed plus 8x squared plus 2x minus 1. And looking at that one, the x-intercepts are the intersection points between the red curve here and the x-axis. So here's the first one. So that's the negative 0 that we are trying to actually predict from using that theorem. So it's 1 negative real 0. And then how many positive zeros? So here's the first one, second positive 0, and the third positive 0. So total of 3 positive real zeros. Okay, and that matches our uh, answers a while ago. So this is how you check by graphing. So for example, you're missing their x-intercept. You don't have a match. Here we have a match. We have 4 and the degree of the polynomial is 4. Now the difference between that, if it doesn't match, it means that's the non-real imaginary zero, or non, uh, it's a complex zero, okay? A non-real complex zero. So that's the term used. Or you can say imaginary zero, okay? Because it cannot be seen from the graph. Only the real zeros will be on your graph. Okay, so that's how we use the Descartes rule of signs.